In this video, we are going to derive the design equation for a batch reactor for a complex reaction network. So our reaction network is going to continue to be the methanol synthesis reaction. We are going to first write the design equation for a batch reactor for a simple reaction, and then we will see how we can add the complexities into it, and then how we are going to use the tensor algebra to simplify the expression. So the design equation for a batch reactor for a simple reaction was dNA over dt to be equal to R sub A times V. Now we have, instead of R sub A, B, C, we have R1, 2. Now remember, during the matrix multiplication, we said that R1 multiplied by A1, this first term, stoichiometric coefficient of A1, all right? So this is nu 1, 1. R1 multiplied by nu 1, 1. Let's apply that logic here. RA is equal to nu A times R times V. This is the more rigorous representation of reaction rate. Now, in a complex scheme, we should be writing this. So let's simple reactions. We should be writing this for complex reactions as dNA over dt to be equal to summation nu A J times R J times V. So we are summing overall the reactions. It is this vector that I'm talking about, right? Nu AJ times RJ is equal to RA. This whole term is equal to RA. So this is for the complex reactions. Now let's take this term, treat it for a constant volume reactor. Remember, when the volume was constant, we were able to bring it into the derivative to write dCA over dt to be equal to summation of nu A J times R J. So this was our row vector. This is our tensor. We have another vector actually. We have a column vector of components. A, B, C, D, E, F components. So let us write those column vectors as a vector AI d over dt. Let's generate our symbolism. dAI A1, 2, 3, 4, 5 is equal to, now I'm going to save time, space, and I'm going to write the stoichiometry matrix as a tensor, and this is a vector when I just throw underneath. when I do double, it's a tensor. Vij times Rj times V. So Ai refers to Ni, number of moles within the system boundary. This is also a vector, all right? I cannot write in boldface on the board, so I have to use a symbolism that reflects that this is a vector. One line underneath represents a vector, two lines represent a two-dimensional vector, which is a tensor. So this is the most general representation of the design equation in vector notation or in tensor notation.